Okay, chapter, one second, let me get a pen. Chapter 3.6. So in chapter 3.6, we're talking about polynomial as well as rational inequality. So let's first start with your polynomial inequality. And remember, inequality means it could have a less than sign, greater than, less than or equal to, greater than or equal to. Those are your inequality signs. The first thing you want to do is make sure you move every term from the right side to the left side. So move every term to the left side so that only 0 is on the right side. So basically, that all it says is make sure 0 is on the right side. Move everything to the left, only 0 should be on the right side. Step 2 is to change inequality sign to an equal sign. And just to make sure you understand what I'm saying, this is your equal sign. And solve for x. Okay? These will become your boundary points. Those are your boundary points. Those will be very important to you. Okay? Then the third step is go ahead and place the boundary points on a number line. Okay? So place your boundary points on a number line and test values on the left and right of the boundary points. And when I say test, make sure you realize you're going to plug it right back into the plug it back into the function. Boundary points. Okay? Then, if it's positive, so when you do your test, if you get a positive answer, or, positive, then you're just going to write a positive sign in that interval. So write a positive sign in that interval. If it's negative, then write a negative sign in that interval. And then the last step is your solution. The solution will be whichever one gives you, your solution is whichever interval holds true to the original inequality. So your solution is whichever interval, whichever interval, I'm going to say gives the correct sign. Gives the correct sign, as in positive versus negative. Okay, let's practice a problem. We're going to look at page 438, and let's look at number 69. Number 69, and I have 2x squared plus 5x minus 3 less than 0. Okay, so the first thing we want to do is make sure everything is on the left side. Only 0 is on the right side. 0 is on the right side. So we're good to go on step 1. Okay? Then step 2 says change this inequality sign to an equal sign. So instead of having 2x squared plus 5x minus 3 less than 0, I'm going to have 2x squared plus 5x minus 3 equals 0. And then I get to solve, right? So let's solve for x. I'm going to use the quadratic. Okay, so I'm going to write off to the side my a, b, and c for you. My a is 2, my b is 5, and my c is negative 3. I'm going to plug into my quadratic. Negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3, all divided by 2 times 2. And this gives me my x's. So it's negative 5 plus or minus the square root of, well, this is 25, and this is 24. When you add them together, you get 49. all over 4, which is going to be negative 5 plus or minus 7 divided by 4. So I have two x's. The first is going to be negative 5 plus 7 over 4, which is just saying 2 over 4, which is a half. And the other one's going to be x is equal to negative 5 minus 7 over 4, which is negative 12 over 4, which is negative 3. So you have two boundary points. One is a half, the other is negative 3. Now you're going to draw your number line and place your boundary points on the number line. So I have negative 3, and I got a half. And I'm going to use this dash line to show you that these are boundary points. Think of them like gates. This is the gate. Now, let's go back up to this inequality sign. This right here just says less than. There is no or equal to. Therefore, on your number line, you should be using parentheses. One opening to the right, one opening to the left, or facing to the right, facing to the left. Parentheses. Remember, use parentheses when you're not including. So, I'm sorry. Parentheses when not including. If it would had an equal sign underneath there, I would have used brackets. Alright, now let's go back to our number line. This interval is negative infinity to negative 3, because it starts off out here at negative infinity, right? And then I run into the negative 3. Then in the middle I have negative 3 comma a half. And on the outside I have a half all the way to infinity. Okay? So now I want to test values. So let's pick a number to the left of negative 3. How about negative 10? A number in between, 0, and a number bigger than, let's go for positive 10. And what you're going to do is plug this into the original function, which is this piece right here. So I'm going to start writing up here. So I have 2 times negative 10 squared plus 5 times negative 10 minus 3. So that is 100. 200, negative 50 makes it 150, so I'm looking at 147. It's positive, so I write the plus sign. Now let's do 2 times 0 squared plus 5 times 0 minus 3 is negative 3, so I have a negative sign here. And then the last one is 10, so I have 2 times 10 squared plus 5 times 10 minus 3 was 100, 200, 250, 247. So this is positive. Okay, great. Now you get to go back to the original inequality problem, and it said less than. Less than means negative. Less than means negative, basically. So which one of these gives you the negative? Will be the middle interval. So your solution, let's use red. So your solution here is going to be negative 3 to a half, and that's it. That's the only place where I have negatives. Now let's say I picked another number from the middle, like 1, and I plugged it in. So up here in red, let's do that. 2 times 1 squared plus 5 times 1 minus 3. Okay, let's make sure that works. Oh shoot, 1 is not inside that interval. You guys let me do that. Let's try again. What is a number that's inside the interval? Well, the interval is negative 3 to a half, so how about negative 1? Let's plug negative 1 in. So 2 times negative 1 squared plus 5 times negative 1 minus 3. Well, what is that? That's 2. Can I not add here? 2. Negative 3, there we go, negative 6, which means it's still negative. It doesn't matter which value I picked inside the interval, it's always going to give me that negative, and I was looking for less than, which means I'm looking for negative. Therefore, this interval is the answer. Great. Let's look at one that has a rational function. Let's look at a rational function. So let's look at number 72. So the steps are still the same, except for the main difference is right here. Step 2, when it says change the inequality sign to an equal sign and solve. When you're dealing with your rational, so let's use a different color. for your rational inequality, instead of setting it equal to 0 to solve, you should set the numerator equal to 0 as well as set the denominator equal to 0 and solve. You must do the top and the bottom. The top and the bottom. Okay, so let's go back. So number 72, we have x minus 6 divided by x plus 2 is greater than 0. So on the right side, we only have the 0, so only 0 is on the right side. So that checks. That's step 1. We're still good there. Good. That's step 1. Step 2 now says we'll set the numerator and the denominator equal to 0. So x minus 6 is equal to 0, as well as x plus 2 is equal to 0, and you solve. So this is x equals 6, and this one is x equals negative 2. Then you get to place these guys on a number line. So I have the negative 2, and I have the 6. Now the question is it a bracket or parentheses? Well, first of all, this x plus 2 equals 0. The x plus 2 came from the denominator. It's always going to be parentheses. I'm never going to include it because I can never divide by 0. Therefore, that's going to be parentheses automatically. Now, the x minus 6 came from the numerator. How I determine if I'm going to use parentheses or brackets is by looking at the inequality sign. This means greater than. Therefore, I'm not including it, so I also must use parentheses. And again, let me draw my dashed line. So these would be my gate. This interval over here is negative infinity to negative 2. The one in the middle is negative 2 to 6. And this is 6 to infinity. Great. 1 second. Let me pause for a second. Hi.
Can you make this is when you from work piece when you guys took it? Can you make sure the rest of those guys get theirs? Thank you so much.
Thank you.
All right.
Okay, I'm back. I'm sorry about that. There was an unannounced visitor at my door. Alright, so I have my points on my number line. Now I want to pick test values. So let's do negative 10, 0, and 10. And I'm going to plug it into this piece right here, the original one, right? So I have negative 10 minus 6 over negative 10 plus 2, which is negative 16 divided by negative 8, which is 2, so it's positive. Good. Now we get to do the 0. 0 minus 6 over 0 plus 2 is negative 6 over 2, which is negative 3, so it's negative. And then the last one is 10 minus 6. Okay, so then the last one is 10 minus 6. 1 second. 10 minus 6 over 10 minus 6 over 10 plus 2, which is going to be 4 divided by 12, which is 1/3, which is positive. Great. Now we got to figure out which one of these intervals is going to give me my answer though, right? So up here I was looking for greater than, which means I'm looking for the positive intervals, right? The ones that give me the positive. So that would be this one as well as this one. So my solution is going to be parentheses negative infinity to negative 2 and 6 to infinity. Oops, not the word and. Union or. So negative infinity to negative 2 or 6 to infinity. Great. So the main takeaway from the rational compared to the polynomial is that you need to set the numerator as well as the denominator equal to 0. The denominator is always going to have parentheses because you never want 0 in the bottom. The numerator depends on the inequality sign. Okay, so that is 3.6. Let me know if you have any questions.